Welcome back. In this video, we'll see an example of round robin algorithm. So, guys, generally round robin algorithm is going to work on the principle of time quantum, which means once CPU get allocated, the process has to execute for only that much amount of time, and it has to come out from that respective CPU. Right? So if you look into the data set, they are given with process ID, arrival time, and the burst. And to work with round robin algorithm, we need definitely time quantum. Right? So to simplify the process of how CPU processor allocated, we'll go with the Gantt chart. Right, guys? We can assume this as a CPU which starts with 0. And we know we are going to maintain ready queue where all the processes which are readily available for running will be placed in the ready queue. Guys, you can go with the previous video if you want to have more clarity on this round robin algorithm. Then you can come back to this video and listen. You can able to solve it easily. Okay, guys, in the ready queue right now there are no processes. At 0 interval of time, is any processor there in the ready queue? No. So as CPU is idle for 2 units of time, there will be a process which is available, means which is arrived at 2 units of time, that is P3. So that will be entered into the ready queue. So once it entered the ready queue, as soon it came, it will be allocated to the CPU for 3 units of time, right? If it allocated 3 units of time and it is left over with 1 unit, right? As soon as it allocates 3 units of time, it will complete by 5 units. Right? By the completion of 5 units, what are the processors available for us? P1, P5 and P4, right? So P1 came at 3 units of time, P5 came at 4 units of time, P4 came at 5 units of time. That's why I have written in this particular order. Right? Yes. By the completion of 5 units, P3 will again enter into ready state. Now we'll be given chance to P1. P1 allocates 3 units of time and left with 3 units, and it is going to complete by 8 units. By the completion of 8 units, one more process is at the ready state. So I will be added to the ready queue P2. Right? Now P1 is left with 3 more units, so it will be added to the ready queue. Then given chance to P5. P5 will be executed for 3 units of time and complete by 11. And as it left with 0 units of time, it won't be added to the ready queue. Next, P4 will be allocated with 3 units of CPU. Then it is left with the 2 units of time. So that means 14. As soon as it completes execution, again it needs to add back to the ready queue. Then it gets the chance to execute P3 and it is left with 1 unit of time. So it will execute for 1 unit and complete by 15. Next, P2 executed for 2 units of time and completed by 70. Next, P1 got the chance, will execute it by 3 units and it will done by 20. Next, P4 got the chance. I think here it will be 2 units of time, so it is 22. This way, your round robin algorithm is going to work. Right? Then, what is the scheduling length here? Maximum completion time of all processes, that is 22, minus minimum arrival time of all processes. Minimum arrival time of all processes is 2, which leads to 20. Okay, guys. So this way your round robin algorithm is going to work. Hope you understood this video clearly.